Hi, everybody. Hope you're doing well and you're safe and you've got a smile on your face. We're going to move into the second chapter, or continue with the second chapter of the Math 71 program, which is entitled Functions and Linear Functions. And we're going specifically now to 2.2, which is dealing with functions and graphs. In other words, being able to look at a graph and not only identify that it's a function, but to be able to identify the domain and the range of that function by looking at its graph. Now, just to bring back a memory for a bit, in 2.1, we defined what a relation was, and we defined what a function was, and then we went into identifying the domain and the range of either a relation or a function by looking at a collection of ordered pairs. But in 2.2, we're going to stay with identifying the domain and the range of a function, but in 2.2, we're not going to be looking at a collection of ordered pairs. We're going to be looking at a graph, which represents a function. So we're going to turn our attention to this sheet of paper right here. You can see there is an X and Y axes. I know the colors might appear to look the same. I just wanted to stay away from the color red. You know already from review, you already know that this axis is the x-axis, and I've marked it. And the vertical one is the y-axis labeled up there. And you can see up there on that x and y coordinate plane, there are a total of 5 graphs labeled A. We will begin with this one. B, C, D, and over here in quadrant number 1, E. And the primary purpose of this first part of this lesson in 2.2 is to be able to take each one of these graphs, which are representative of functions, and to be able to identify the domain, which we already know is associated with x, and the range, which we also know is associated with y. When we identify the domain and the range for each one of these graphs up here, we are going to be using a particular kind of notation. The notation that we're going to be using is a notation that you should already be aware of, and it's called interval notation. Interval notation is used when we are solving inequalities and graphing inequalities. Interval notation is used for that. And interval notation is also used to identify the domain and the range of functions when those functions are represented by graphs. I might also just mention this as somewhat of a review before we begin. When we are using interval notation to identify domain and range, we will be using very specific looking symbols. And these symbols that I'll be alluding to right here should not be new to you. We will be using brackets. We'll either be using a portion of a bracket like this one right here that is opening to the right, or a bracket that is opening to the left, a parenthesis that is opening to the right, or a parenthesis that's opening to the left. We'll be using a positive infinity symbol, and we very likely today might be using a negative infinity symbol. Interval notation uses brackets, parentheses, and the infinity symbol. And we'll point that out when we begin to identify the domain and the range. The first thing that I want to cover when looking at this coordinate plane and the graphs that are up there, one thing that I want to just discuss for a moment is we are able to obtain information by looking at the graphs up here, and it is very important to talk about this information. If you take a look, and you've already been maybe looking at some of these graphs up here, you might take a look at the end points of each of these graphs that are up here. Some of the end points are darkened points. Darkened, 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 darkened. A second end point is an open circle. Open, 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 open. And then a third endpoint symbol is way over here in quadrant 2, an arrow. Let's go back to the darkened point for a second. I'll start with this one right here and just go with this one. The meaning of the darkened point is this. The graph for letter A is not going to be any value less than -2. It's going to stop right at that point. It doesn't keep going. So a darkened point means it's going to end or begin at that point, and the number that is associated with that point, for example, -2 for that point, it counts. It's part of the graph. A darkened point means it counts. It's part of the graph. An open circle here, I'll just hold it right there. An open circle indicates two things. The graph does not go beyond that point. It'll begin right at that point, but an open circle indicates that that point is not part of the graph. So open, not part of the graph. Closed, part of the graph. And then the third and final little end behavior symbol is an arrow. And you should already know that the arrow indicates that the graph is going to continue to move in the direction that that arrow is pointing, and it will continue to go and go and go and go. And in this case, it's going to move infinitely in a negative direction because the negative real numbers are moving to the left. And this graph is moving to the left, so this graph is going to move infinitely negatively. So arrow, darkened point, open point. That is a bit of information that we wanted to speak to first before we actually would get into the concept of domain and range. Now, what I'm going to try to do is I begin with graph A. This is graph A. We'll do him first. Then we'll move down and do graph B. Then we'll go up and do graph C, then D, and then E. And there is one and only one objective that we're going to be doing with each of these 5 functional graphs. We're going to identify the domain of each graph, and we're going to identify the range. And I'm going to try my best not to do a lot of marking up on the x-axis and try to limit my shading or my marking on the y-axis. So I'm going to try to do my best to not have to clutter this coordinate plane up and make it messy. Before we begin, let's just acknowledge that A, B, C, D, and E, they are all functions because they all pass the vertical line test. I'm not going to draw vertical lines. I'll just do it with my pen. Letter A, vertical line. It only intersected that graph at exactly 1 point. B, 1 point. C, doesn't matter where you put the vertical line, 1 point. D, 1 point. And even E. Note, this, and this is considered the graph. It passes the vertical line test here. But let me mention this as Kristen is holding it right here. This darkened point is right in line with this open circle. So if you send the vertical line down through that point, it's only going to intersect that overall graph at just that point. Although it will run through him, he doesn't count because he's open. So if some of you are thinking that it would fail the vertical line test right here, it doesn't, because he's not a part of this portion of the graph. He doesn't count. So he's actually the only point right here that vertical line will touch. And likewise here. So they're all functions. They're all functions. Now, let's go to letter A, and let's show you how we're going to identify the domain. Remember, the domain is associated with X. All of the numbers, all of the real numbers that are on the x-axis are potential domains because X is affiliated with domain. So these are domain values right here. All of these values that are on the x-axis. Now, if we want to identify the domain of this graph right here, we're going to start at the smallest value that would appear on this graph. And the smallest value that would appear on this graph would be this point right here at -2. The highest point, or the largest value on this graph, domain-wise, x value-wise, it's going out as far as x is 1. Here's how we identify the domain. We are going to take all of these points, all of these that I'm scanning with my index finger right here, we're going to take all of these points and we're going to theoretically move them all down to the x-axis. And once they've been all moved down to the x-axis, then we will be able to see the smallest domain value and the largest domain value. Now again, like I said, I was going to try to do this without monkeying around with this and messing it up. This smallest x value of -2, notice it's already on the x-axis. So right now, the smallest domain value of this graph is -2. And because it's a darkened point there, it counts. So just acknowledge the smallest value of the domain is going to be -2. Now you see all of these values right here stopping at the point of this y-axis right here, they will all come down. So when they come down, all of this x-axis is going to be filled up right here. All of these x values right here. And then all of these points stopping right there, they're all going to come down. They're all coming down on the x-axis. This positive 1 right there, which is associated with that endpoint right there, that endpoint is the final point that's going to come down. So the largest domain value is 1, and the smallest domain value is -2. I could darken this right here, but it is this portion of the x-axis right here, with him counting and with him counting, and all of those in there, which is going to be affiliated with our domain. So I'm going to come over here on number 1. We start with our smallest value, which is a domain value of -2. And because he's darkened, he counts. And the symbol that we use to show that he counts is a bracket. So we're going to begin. Letter A for the domain. We're going to put a bracket that's going to open to the right. And right next to that bracket, we're going to put that smallest member of the domain, -2. And we put a comma. Right now, that indicates that the domain of this graph is going to begin at -2, and -2 counts because it's got a bracket to its left. The largest value of the domain is right here at +1, and it's darkened up, just like he was. It's darkened. So I put that darkened point right there. +1 is the largest domain value. We put that after the comma. And because it is a darkened point, we use a bracket again, but this time we put the bracket and open it to the left. That is the interval notation for the domain of graph A. Its smallest member is -2, its largest member is +1, and all of the real numbers in between those two real numbers are part of the domain. It's not just -2 and +1, it's all of these. It's all of these as well. Now, that's the domain. Now we're going to go to the range. Down here again, I already alluded to this, but just keep this in mind. The range is affiliated with y. So, to find the range, we are now going to do the following. We're going to take all of the points on this graph, and we're going to move them all over to the y-axis, because range is affiliated with y. So we would be doing something like this, and I'll try to do it. We're going to take this lowest value of the domain here, this -2, this point, and it's darkened, and we're going to move that point over to the y-axis. Why? Because every value that's on the y-axis is affiliated with range. So I'm going to move that point. I'll start with that. I'm going to move him over right there. That is our smallest range value. I moved him. He counts on that graph. I'm moving him over to the y-axis. That is my smallest range value. Now, folks, all of these, when they move over, they're going to fill up this. They're going to fill up all that. And all of these points, with this one being the largest, it stops right there. I'll go ahead and go to this highest one right here, and let's move that point over to the y-axis. It would meet right here. Right there. And all of these, they're moving right over. This is the highest range value. This is the lowest. And everything in between has been filled in from that portion of the graph and that. We go to the range. Move this one over. He's the smallest range value. He's 0. He counts because it's darkened. And the highest range value, I took that point, moved him over, is 3. And he counts. There's the range. Okay. Let's go to B. He's a loner down here. That's one of the endpoints, and he's open. So even though the number is going to count, even though the number is going to be written down, this point is not part of the graph. However, on the other end, that point is. So let's do domain first. Folks, domain X. I'm going to take this little puppy right here. Even though he doesn't count, I'm going to move him up to the X. And I'll put a circle there. That is the smallest domain value. And he doesn't count. So right now, he's not going to get a bracket. He will not get a bracket. He's going to get a parenthesis in a moment. All of these, right here, all of those points, they're going up. All of these. I'll do him first. He's darkened. Move him straight up. He's right at an X value of 2. This entire little portion of that X-axis is going to be filled in. You can see it. There's the smallest domain. And that smallest domain is -1. But it's got an open circle. So we'll go to B. Because it is an open circle, we use a parenthesis. And we open that parenthesis to the right. Because this graph is starting right here at its lowest end of -1, and it's moving to the right. Put a -1 there, comma. The largest domain value is 2, and he counts. Bracket, domain. Every single number in between those, including -1 and +2, make up the domain. Range. Range. Y. Y-axis. Let's start with this lowest one. Move this open circle over to the y-axis. Move this largest point, the point to the right, move that over to the y. Darkened. Smallest, largest. And all of these points, all of these, they're moving over. All of those, they're moving over, and they'll fill this. All of these are moving over, and they'll fill that. That little interval, that represents your range. We begin with the smallest. That's an open circle. Parenthesis, -2, comma, largest, -1, and it's darkened. It counts. Bracket, done. Let's go up here. Quadrant 1, quadrant 2. Function. Let's identify domain. Here's the endpoint on the left. He's going to represent the smallest domain value. And he'll represent the largest. Take this point, bring it straight down to the X. It's here. It's right there. That's our smallest value. And he's darkened. He's going to get a bracket in a moment. He counts. All of this. Come down. Fill all the rest of this x-axis right here. And all of these points, come down and fill the rest. This was our other endpoint. It corresponds to a domain value of 1. He's going to get an open. Smallest. Largest. Smallest counts. Domain. Bracket. -3. Highest, greatest domain value was him. I brought him straight down to the x-axis, and he's an open circle. He doesn't count, but we still write the 1, but he gets a parenthesis. There's our domain. Range. Move all of them over. All of these emanating with him, move him over to this point, theoretically. And this point right here, this is going to be, all of these points right here are going to come over. Now, keep in mind, this is that's a little open circle right there. That's open. All of these values here will come over and fill this. Now, here's where we want to be a little bit careful, just so that there's no mix-up. Right about here, you see there's no gaps here. Sooner or later, this point that's right about here is going to come over and fill in that open circle. It's like this point, if I can use this form of language, this point right about here is going to trump that point. You see, he didn't count when I first put him over there, but he will count because this is part of the graph right here, and he's going to come over and he's going to fill that up. This point right here will come over and fill up 5. So don't go thinking that that is an open circle. He was just temporarily open. He got trumped by this point right here that's going to get moved over. So it's all filled up. Now there's our smallest range, and he counts. There's our largest range, and he counts. Smallest. A bracket, 3. Highest, 5. And he counts. There's our range. I hope you're seeing this, folks. I think if I was listening to this, I think I would be getting it. I really do. Let's go to D. There's not really any interruption right here. Let's move through it. It begins at this point. It does not continue on. It begins right there, and he's part of it. And then you'll notice it's moving negatively, infinitely. There's no end point. There's no open circle. There's no darkened point. It goes infinitely. This just happened. Got to be careful here. This point right here is -3. All of these points are going to come down to this portion of the x-axis and begin to fill up all of this. And all of it continuously. And the entire number line moving in a negative direction is going to get filled in, because this graph is going to continue to move up and up and up and out. And so you're looking at the domain right here. Be careful. He's the largest value. These are smaller. And it's going infinitely. So when we do the domain of letter D, the infinity symbol, which is going to be a negative infinity symbol, always gets a parenthesis. Let me say it again. The infinity symbol, whether it's positive infinity or negative infinity, will always get a parenthesis. The negative infinity comes first because it's all of these values that happen to be less than -3. So we put a parenthesis and we put the negative infinity symbol, then the comma, and then we put the largest one. He counts, he's -3, and he gets a bracket. Let's do range. Range. We take this lowermost point on the right of this graph, which he counts, move him over to the y-axis. He's darkened. He's going to be the smallest value. He'll be the smallest. Counts. If you take all of these points, let's just do this much right here up to that arrow. That would fill up about this part. But you see, folks, this is going to continue to not only move out further and further and further to the left, it's going to keep ascending. It's going to keep ascending, people. And as it keeps ascending, all of those points are going to move over on this y-axis. And the entire y-axis to a positive infinity will be filled up. Because he's never stopping, and he's going to keep ascending. Positive infinity, parenthesis, done. And finally, E. Let's do domain. Start here. Bring him straight down. All of these, I'm not going to touch him yet. All of those would fill. This point, he trumps him. Whereas he doesn't count. That little puppy right there is right above him. He counts. He comes straight down. All of these. He doesn't count. But this guy is right above him. He trumps, this guy trumps him. So he comes down and he fills up that domain value of 4. And then we fill in all of those. And then finally, right at this point, there is no other portion of the graph. So this open circle right here will be positioned right at +5. There's the smallest domain. And there's the largest. And he doesn't count. So domain 2, he counts, bracket. 5 is going to be written last, and he's going to get a parenthesis because it's an open circle. The graph does not include 5. It's every value up to 5. And now the range. And this is a unique one. Because if you look at this graph, it's sort of a disjointed graph. When we go to the range, every single point on this portion of the graph is going to come over to the y-axis. Since this is the last one, I'm going to make it bold. One of our range values is going to be 1. Because all of those points come over there. This is the second part of our graph. All of these, they're going to come over a range value of 2. But if you're wondering, none of this, none of these. Just this distinct point, but none of those, because it's not here. And then this portion, move it over that distinct point. When the points are distinct, not moving together, not all these points moving together, but singular points, 1, 2, 3. You cannot use interval notation. You'll have to use roster notation. And roster notation makes use of braces. No parenthesis, no bracket, because it is a discrete set of values. 1, 2, 3, done. Now, people, I don't think I'd change anything that I said today, and my only concern is that this video is going to get done, and you'll see it. I wouldn't change anything that I said about it. I think you should walk away from that graph saying, I've got the tiger by the tail. I know exactly what you're talking about right there, and we hope that you do. Okay? Now, we're going to close this section of 2.2 off. There, and that will take, by the way, that will take care of 2.2. We'll be moving into 2.3 and be making some comments about that. Take care.